All right, so in our last chapter, we talked about atoms and elements and all of the different types of elements. And we talked about elements that have a charge, which are called ions. Okay, any atom that has a charge is called an ion. More specifically, we need to know that a cation has a positive charge, and an anion has a negative charge, right? Those are things that are really, really going to be important for this chapter. So last chapter, we introduced elements and atoms and all those types of things. And in this chapter, what we're going to focus on is chemical naming. We're actually going to learn how to name chemical compounds. All right, we're going to start with really basic compounds, but we're going to start with how to name chemicals and how do we name compounds. Okay, so in order to do that, we've got to have some background knowledge, especially about cations and anions. We have to know that cations have a positive charge and anions have a negative charge. Okay, so as we start to go through this lesson, I want you to pull out your periodic table of ions, which looks like this, right? It's on the back side of your regular periodic table. It's got a periodic table of ions all on it. That is going to be something that we are going to use a lot for this chapter. So we're going to need this ions side because it not only tells us, it doesn't just tell us the ion, it doesn't just tell us the element itself, it tells us the charge of these elements, right? It's a periodic table of ions. So it tells us the charge of the atoms as well. So we need that out for what we're going to be doing in this chapter. So the type of naming that we are going to start with is called ionic naming. It's called ionic naming. All right, and what ionic naming is, it is a chemical formula. Right, ionic compounds are chemical compounds formed between a metal cation and a non-metal anion. Okay, it's made between a metal cation and a non-metal anion. So look at your periodic table of ions and look at how it's split, right? Here is the stair step. And we know metals are all to the left of that on the stair step. Non-metals cover this section of the periodic table. If you'll notice, all the metals have a positive charge, right? Every element on this side of the periodic table has a positive charge. Every element on this side of the periodic table has a negative charge. So when an ionic compound is formed, we're going to take an element from this side and an element from this side, and we're going to bond them together. That's what an ionic compound is. It is between a metal, which is over here, and a non-metal. Okay, so let me clear that off again. Okay, metals are on this side of the periodic table, and non-metals are on this side of the periodic table. Okay, metals all have a positive charge, non-metals have a negative charge. Cations, anions. Okay, so I hope you see the difference there on your periodic table of ions. We're able to see that. All right, so what I want us to look at now is how these charges kind of come about. So we have a better idea of how these charges are determined. Okay, so let's look over here first in group 1. Look at group 1 on your periodic table of ions. Every single element in that group has a charge of +1. And what is it that we know about the elements in group 1? Okay, elements in group 1 all have one valence electron. Okay, elements in group 1 all have one valence electron. We know that from last chapter, right? When we talked about the periodic table and the groups, we know that elements in group 1 have one valence electron. And we said they're more likely to give away that electron than to gather in 7 more. So if they're going to give away an electron, okay, let's look at lithium, for example. Lithium starts with 3 protons and 3 electrons. If they're going to give away one of their electrons to complete that innermost shell, that leaves me with 2 electrons. What charge does that leave me with? 3 protons and 2 electrons leaves me with a +1 charge. That's how the charges in group 1 are determined. They readily and very quickly give away their valence electron, their single valence electron. They give it away. And so now they are short 1 electron, which leaves them with a +1 charge. That's how the charge is determined. If we look now at group 2, all these elements have a +2 charge. Okay, they all have a +2 charge. Okay, look at your periodic table to see this. They all have a +2 charge. So magnesium, beryllium, calcium, all of them have 2 valence electrons. And it's going to be easier for them to give away 2 than to bring in 6 so that they can have a complete shell. So if they give away their 2 electrons, that's going to leave them short 2 electrons. And so again, if we look at, let's look at calcium here real quick. Calcium has 20 protons. It would normally, if it was neutral, have 20 electrons, but we said they're going to give away those 2 outermost ones, and that will leave them with 18 electrons. So if we have 20 protons and 18 electrons, that leaves me with a +2 charge, right? So that's how these are determined. Let's flip over to the nonmetal side and look at the halogens right here in group 17. Let's look at chloride, for example. Chloride has 7 valence electrons. And so rather than give away 7 valence electrons, what they want to do is take an electron from somebody else. That would mean they've got 8 in their outer shell now, which is what they want. And so now they take on an extra electron, which leaves them with a charge of -1. So if we look specifically at chlorine, normally chlorine has 17 protons and 17 electrons. But we said if they're going to take on that extra electron so that they can complete their shell, now we've got 18 electrons and 17 protons, which means we've got a charge of -1. All right, so I just wanted you to have a little background about how the charges on elements are formed. It's not just an arbitrary number. It was not chosen. It has to deal with how electrons come and go and how atoms want their electrons to have a complete shell. So now that we know how the charges come about, we're going to start learning how they are named. We're going to learn how they're named. We're going to start with first something called monatomic ions. Okay, just based on this word monatomic, the prefix mono means 1. So these are just ions of a single atom. We've looked at some monatomic ions before. Monatomic ions are things like O -2, Li +1, Ca plus 2. S minus 2, right? These are all examples of monatomic ions because it is a single atom with a charge. Okay, and so when we name monatomic ions, we have some rules, but these rules really are laid out on your periodic table of ions. Okay, the rules for naming monatomic ions is very simple. The cations, if it's a cation, they keep their name. Okay, cations get to keep their name. And so if we were looking at Li plus 1, it's still just called lithium, but you might say lithium plus 1. So we know we're talking about the ion version rather than the neutral version. Okay, but when we're naming a monatomic anion, it works a little differently. Anions don't get to keep their regular name. They end their name with IDE. Okay, so now their name changes a little bit to tell us that we're focusing on the anion version of that atom rather than the neutral version. So O minus 2, instead of being oxygen, would be called oxide. Oxide, all right? And the IDE tells me I'm dealing with the charged version of oxygen. I'm not just dealing with O. I'm dealing with O minus 2. So I want you to look very carefully at your periodic table of ions. And I want you to see over here on the non-metal side, right? All of these that have a charge already are written as IDE. Okay, the ones that have a charge are written as IDE. Okay, if they have a -1 charge or a -2 or a -3, whatever their negative charge is, you see them already ending with IDE. So they helped you name the monatomic ions on this right-hand side of the periodic table. There are some that do not end in IDE, like carbon, boron, silicon. These three don't, even though they're nonmetals, because their charge changes a little bit, right? Carbon has 4 valence electrons, and so it's just as easy for carbon to give away 4 as it is for carbon to bring in 4. So carbon's charge is determined by what it wants to bond with. And so it's not written on the periodic table of ions because it changes a little bit. Same with silicon and boron. Okay? So we see IDE for anything with a negative charge. The noble gases are not written with negative charges because remember, they already have 8 valence electrons. They don't want to take on electrons. They don't want to give them away. They want to just stay by themselves. So they're not usually involved in bonding or forming chemical compounds. So if I was going to ask you, what is the name of this molecule, this atom, P minus 3? Okay, well, it has a negative charge, so it's an anion, which means it has to be on the right side of your periodic table. And you know it's phosphorus, right? It's made of phosphorus, so we look for the P. But it's a negatively charged phosphorus, so the name of it would just be phosphide. Phosphide. Okay? Likewise, if I asked you for what's the symbol for bromide, you would tell me it's not just Br, it's Br minus 1, because that's the charge that is attached to it. Okay, I want to point out that on your periodic table of ions, it shows them as 2 minus, and I write them as minus 2. Those two things mean exactly the same thing. right? This is a 2 negative charge, and this is a negative 2 charge. They mean exactly the same thing. So I don't want you to be confused by the way that that is written. But bromide is right here. If it's just written as Br minus, we assume that there's a 1 that goes there. The same thing is true for if it's a +1 charge over here. Li plus is the same as Li plus 1, right? If there's not a number that comes after that, plus or minus, then we assume it's a 1. So now we've looked at naming some basic compounds. We looked at anions. If I had asked you to give me the name of potassium plus 1, you would just call that potassium. It's not potassiide or potasside or anything like that because it's a positive charge. And the rule is that if it is a cation, right, a positive charge, it keeps its regular name with its regular ending. Okay, so the name for K plus 1 would just be potassium, right? So let's move now into something called binary compounds. Binary compounds. Bi means 2. So binary compounds are compounds made from 2 elements. Compounds made from only 2 elements. Okay, we need to know that binary compounds are made of 2 elements, and we need to know that these compounds have an overall neutral charge. So when we say they have a neutral charge, that means a charge of 0. That means our positive charge has to equal our negative charge. Okay, they have to cancel each other out. So let's start with a simple binary compound. Let's say that I wanted to form a compound with potassium and chlorine. Potassium and chlorine. So when I go to form this compound, I can't just form it with neutral atoms. I have to form it with their ions. So I look and I find, well, what is the charge for each of these atoms? +1 and -1. So I have to look now, do these charges cancel each other out? +1, -1, that means they do, right? A +1 and a -1 cancel each other out, which means the formula is KCl, right? That is the formula of a compound, a binary compound between potassium and chlorine. But when we name that compound, right, this is called the chemical formula because it is the formula of that compound. But the name of the compound is easy to name. All we do is we name the cation and then the anion. So it would be called potassium chloride because we used the -1 version of chlorine. We didn't just use chlorine neutral. We used chlorine -1. Okay, so it has to be called chloride. Potassium keeps its regular name. The anion gets an IDE. All right, something else I want you to write down here about binary compounds is not only that their charge has to equal 0, but the order in which we write these elements, we always write them with the cation first. So the cation comes first, then the anion. So when we write them, it's a positive charge, then a negative charge. Okay, the positively charged element comes first. The negatively charged element or atom comes second. So let's try another one here. Let's say I had a compound between calcium and oxygen. Okay, I want to build a formula between calcium and oxygen. So I need to look at what their charges are. So look at your periodic table of ions and find calcium. It's in group 2. Calcium is a +2. Oxide is a -2. So I'm going to look and see, do those charges cancel each other out? And they do. +2 -2 equals 0, right? That makes a neutral charge, which means my formula is going to be CaO. Calcium is the positive charge, so it has to come first. Oxide is the negative charge, it goes second. So this is the chemical formula. And then the name, just the written name of the molecule, would be calcium, keeps its regular name. And then what do we call O? That was charged, not oxygen, but oxide. So calcium oxide. Let's say now that I wanted to have a chemical formula or a new compound between phosphide and aluminum. The first thing we need to do is pick out what their charges are. Phosphide is -3, aluminum is +3. But when I go to write the formula, I don't do PAL because the cation has to come first. So I would go move that around and say the formula is ALP, right? +3 and -3 cancel each other out, so it goes together perfectly. But the cation, aluminum, has to be listed first. Okay, it has to be listed first. So this is the chemical formula. And then the name of this molecule would be aluminum. And then the P with a minus charge is not called phosphorus, it is called phosphide. Phosphide. Aluminum phosphide is the name. ALP would be the chemical formula. So now I want you to give me the chemical formula of the compound sodium fluoride. Okay, I'm telling you that this is the name, and then you need to give me the chemical formula. Okay, the first thing I'm going to do here is I'm going to look at each of them individually. So sodium is Na, and its charge is +1. Fluoride is just F, and look at your periodic table of ions. It has a charge of -1. So these two will go together perfectly, right? +1 balances perfectly with -1. And so now when they come together, we've got the cation coming first, then the anion coming second, which means it would look like this, NaF. That would be my chemical formula. Let's try a couple more of those. Give me the formula for the following. I'm going to give you the name and you give me the formula. So the first one, let's do strontium. Strontium sulfide. You're going to give me the formula. And then I want you to do magnesium oxide. Okay, so go ahead and pause it. Figure out what those chemical formulas should be, and then when you resume, I'll talk through with them. Strontium is Sr +2, sulfide is -2, These charges balance each other out perfectly, which means my chemical formula is just SRS. Okay, we need to be very, very cognizant of the fact that when we write an element that has two letters, the first one's uppercase, the second one is lowercase. So we would not write SRS, right? That means very different things. It's strontium sulfide. Okay, as I look at the second one, I'm going to see, well, what's magnesium and its charge? Magnesium is +2. Oxide is O -2. They're going to go together perfectly because the +2 and the -2 cancel each other out, which means it would be MgO. All right, lastly here, I'm going to give you the chemical formula, and I want you to give me the written name. All right, I'm going to give you CAS and GAN. Okay, so go ahead and pause the video, get it worked out, and then go ahead and resume. Ca is calcium, and S, not sulfur, but we used the negative version, which is sulfide, so calcium sulfide. Ga is our cation here, right? It always has to go cation, then anion. So this is gallium. And then I use the negative version of nitrogen, which is called nitride. So gallium nitride.